Alright, this is the extended video, 8.4 part 2, Sum and Differences of Radical Expression. Let's try some more here. If the other one didn't make sense to you, hopefully this will help you out a little bit more. Alright, we're good. Alright, so here we go. If I'm taking a look at this problem, this person here thinks, hey, simplify when I can or where I can. Well, let's see where we can simplify. Let's take a look. Rad 12, I can simplify that. That breaks up to radical 4 times radical 3. 6 rad 3, well, you can tell that inside the radical symbol it's a prime number. I'm not going to be able to simplify that. It stays the same. Here, 6 is not a prime number, but there isn't a perfect square that can be pulled out of there. No factors. So I'm going to leave that the same alone as well. All right, so then let's jump over here. Radical 4 turns into 2. Rad 3 stays the same. And now I just write these two down here. Now I notice that both of these have the same radical, the radicand. They match. So those two numbers up front can combine, the 2 and the 6. Now the radical 3 and radical 3 stay the same. It's almost as if this was 2x plus 6x, and that would give you that portion here, right? So we have 2 and 6 gives you 8 rad 3. That stayed alone. There's my answer there. Okay? All right, let's go for the more challenging stuff. Let's see this one. This young lady here says to distribute first, and she's correct. So we're going to distribute. Let's see, this rad 5 distributes to both of these terms inside, and so let's take a look to see how we got this. So 5 times radical 5, that's there. We just put the 5 up front. Then a negative rad 5 and a positive rad 5. You just leave the negative out and multiply those two factors inside there. So right here I can notice that square root of 25, I can simplify that part. This doesn't simplify, so that stays the same, but minus rad 25, which is 5. And that's my final answer there. All right, one more. What about those binomials? This guy over here says, hey, isn't that two binomials multiplying with each other? Well, yes, it is, young man. Oh, so I'll use, what will you use? Oh, you will notice that, hey, if it's a binomial squared, isn't that just the same thing as multiplying by itself? And if that's the case, then I'm going to probably want to use one of those area multiplication things, right? So I write 2 rad 5 plus 7, 2 rad 5 plus 7, and then one at a time I fill in the boxes. 2 times 2 is 4, rad 5 times rad 5 is rad 25. 7 times 2 is 14, and then rad 5, same thing here. And then 7 times 7 is 49. I wrote that all to the side here, and I started to simplify. 4 times rad 25, well, rad 25 is really just 5, so 4 times 5. These two have the same radical, so I can add those together, the front numbers here. It's 28, rad 5, and then 49 is just 49. So I get 20 here. All that stays the same. I can now take 20 and 49 and add it, and then there's your final answer. All right? Hopefully that helps out a little bit more.